Okay, Wildcats. Today we're looking at journal page 17, solving absolute value equations. Definition: absolute value of x is x when x is greater than or equal to 0, and negative x when x is less than or equal to 0. Solving absolute value equations by graphing steps. Step 1, graph the right side. Step 2, graph the left side. Step 3, find the x values of the intersection. Okay, the types of the absolute value equation solutions. It's one solution when the absolute value equals 0, and the left and right side intersect at one point. There's two solutions when the absolute value of x is equal to a positive number and the left and right side intersect at 2 points. There's no solution when the absolute value of x is equal to a negative number and they do not intersect. Okay? All right. Solving absolute value equation algebraically steps. Step 1, isolate the absolute value. Step 2, apply the definition. The absolute value of x equals a positive number and the absolute value of x equals a negative number. Step 3, solve for x. Now, in order to not make an extremely long video for you, which I thought you might appreciate, instead of doing examples for these, I've included the work and I've worked out all the problems in the tutorial video for 2.2 solving absolute value equations. So if you have trouble with solving algebraically, please check out my tutorial for the 2.2 my.hrw.com solving absolute value equations. Okay. All right. So let's take a look at the next page. Okay. Example 1, solving absolute value equations. Journal page 17. Example 1, solve the absolute value equation. The absolute value of x minus 4 plus 2 equals 2 by graphing. Okay, so I'm going to start by graphing the right side. Now that's a horizontal line at 2. Okay, and I'm going to graph that in yellow. And I'm going to graph the left side in blue. Now you can see there's two transformations. There's a right 4 and up 2. So we start at the origin and we go right 1, 2, 3, 4, up 2. Now we know because it's absolute value that it goes right 1, up 1, right 1, up 1, and we go left 1, up 1, left 1, up 1. And we know that because the absolute value makes a V, and that's how you get the V. Right 1 from the vertex, right 1, up 1, next point, right 1, up 1. Okay? Now, we can see from the notes that these intersect at one point, so there's one solution. And that x value is equal to, so we come down to the x, 1, 2, 3, 4. So x equals 4 is the solution. Okay, so go ahead and finish up example 1. All right, now let's take a look at example 2. Solve the absolute value equation. The absolute value of x plus 4 minus 2 equals 2 by graphing. So again, I'm going to graph the right side, which is a horizontal line at 2. Okay. And now I'm going to graph the left side. I'm going to graph that in blue. Okay. Now we know there's two transformations. We go left 4, down 2. So from the origin, we go left 1, 2, 3, 4, and then down 2. Now again, we know the absolute value. To get the shape, we go right 1, up 1, 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 and so on. Okay, and then we go left 1, up 1, 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 left 1, up 1. Okay. Now we see that they intersect twice here and here, so there's two solutions. Okay, and so we look for the x value. So x equals 0, and x equals negative 1, 2, 3, 4, 5, 6, 7, 8. X equals negative 8. So again, here and here are the x values. So x equals 0 and x equals negative 8. All right, so go ahead and finish up example 2. All right, now let's take a look at example 3. Solve the absolute value equation. Absolute value of x minus 4 plus 5 equals 2 by graphing. So again, we're going to graph the right side, which is a horizontal line at 2. Okay, now, sorry, dropping my yellow pen there. All right, so now we're going to graph the left side in blue. So we know that we're going to go right 4, up 5. So from the origin, we go right 1, 2, 3, 4, up 1, 2, 3, 4, 5. So always good to double check your count. And we know from the vertex, we go right 1, up 1, right 1, up 1, right 1, up 1. You go left 1, up 1, left 1, up 1, left 1, up 1. Looks like I accidentally went too far, but no worries. I recommend if you haven't got the big whiteout is amazing, so we're going to use that. To start working. Oh. There we go. All right, now we can see that the left and right side do not intersect, so we know that there are no solutions. Okay, go ahead and finish up your notes and examples, and then start working on your my.hrw.com assignment, and have a wonderful Wildcat day.